Hi guys, welcome back to my channel. I am Bearded Dev and today we're going to be looking at joins. So what are we going to cover today? We're going to be looking at inner joins and left outer joins or left joins. I hope you guys are really excited. Joins are something we work with quite a lot in SQL. Once you've mastered them and got a really good understanding, it's a real good sense of achievement and you feel really confident that you know how to work with SQL. As you can see on this slide here, before we move on to the Management Studio, we've got two Venn diagrams. And we're going to do something unusual. We're going to start with the one at the bottom first, so an inner join. Venn diagrams are a great way to show how joins work. So as we can see, we've got a table A and a table B. Now an inner join, when we join two tables together using that inner join, it will return us the results where there are matching in both tables. Let's think of an example. Let's call table A our customers and table B orders. So every customer in table A that also exists in table B orders. So every customer that has placed an order will be returned when using an inner join. So we take the customers table, we inner join that to the orders table. If that customer ID, if that's what we're using, exists in the customers table as well as the orders table, we're going to have a match and those results are going to be returned. What is the difference between an inner join and a left join? It can also be called left outer join. Outer is just the type of join that it is. You don't have to put the word outer, that is optional. I always prefer to do it myself. Some people don't, but if you see left join or left outer join, they mean exactly the same thing. If we look at our Venn diagram at the top under left join, we can see table A is fully complete, our circle for table A. So if we use the example that we did with the inner join, table A is our customers and table B is our orders. What we're going to return with the left join is all of our customers as well as the customers that have placed orders. So we'll have some customers that haven't placed orders, they will be returned, that data will come back to us in the results grid, and we will have some customers that have placed orders which will also be returned. So we're going to jump over to SQL now and I'm going to give you a demo of how these types of joins work. There are other types of joins in SQL that we will be covering in another video, but these are the most commonly used. We've jumped over to SQL Server Management Studio now, and I'm going to open up a new query against the Bookshop database. Right, let's get into it. So I want to run from our customers, I want to get our customer ID, the first name of our customer, and the last name of our customer as well. So if we run this query now, I'll just click F5. We've got 5 customers. We want to have a look at the customers and we want to join that to the orders table. Remember, databases that we're working with in SQL mainly are relational databases, so there are relationships between the tables, we are able to join them. Let's have a look at the orders table. So I'll run this query. So in here we've got a column, our second column, O_C_ID, that stands for our customer ID. So we can use that to join the customers table to the orders table. Now if I was to join the customer ID from the customers table to the OID in the orders table, that would still work. SQL wouldn't know that there is a relationship between those columns in each table. As long as there's a match, SQL is correct to return those results, and we will go on to that in a bit. So at the moment I'll get rid of that query. So we've got our customer ID, our first name and our last name from the customers table. what we want to do now is after we've written from our customers table, we want to inner join our orders table. So that is the syntax for an inner join. We have our from, and then we have inner join table name. But we also need to tell the database engine what does it want to join on. What columns should I be looking for that match in those two tables? So we're going to put the word on. On indicates match on these columns. So we're going to be looking for the customer ID from the customers table, and that needs to equal the order customer ID. So as we can see here, we've got select customer ID, customer first name, customer last name, and we can also, within our select statement, I'm just going to drop this from onto the second line so it looks more readable. At the moment we're only returning columns from the customers table, so what we'll drop in here is ODate and OTotal as well. So we're returning data from both tables. Let's execute that query. As we can see, we've got our customers joined to our orders, matching on customer ID. Now we've got 3 results for Michael, 2 for Paul and 1 for Sandra. And that's because they have multiple rows against that customer ID. So you could be joining to a table that's a one-to-many relationship. It could be a one-to-one, so you're only expecting 1 row per customer, but in this case it's a one-to-many. One customer can have many orders, which is what's happened in this case. So our customer Michael Smith has got 3 orders, and that's why we've got 3 sets of results being returned. As we can see, the dates are different and the totals are different as well. So if we remember the Venn diagram that we showed at the start of the video for an inner join, we have our left input, which is our customers, we overlap our right input, which is our orders table, and we return the results that match in both tables. I'll just write a query selecting all from customers here, and we will see, I'll run them both at the same time actually. So we've got our join as the top results grid, and then we've got our list of customers. As we can see, our customer IDs go up to 5, so we've got Michelle and we've got Tony. They're new customers to us, but they haven't placed any orders yet. So because we're inner joining, they haven't got their customer ID in the orders table, which is why they're not being returned when we use an inner join. But now we're going to move on to a left join or a left outer join. So we're going to write exactly the same query again. So I'm going to select customer ID, customer first name, customer last name, and then we've got ODate and we've got OTotal. I'll just drop this from onto the second line again. Remember, it doesn't matter if there's any white space in SQL, as long as you highlight the whole query, it will be executed. And what we're going to do now is we're going to left outer join DBO orders on customer ID equals order customer ID. Now thinking back to the Venn diagrams with a left outer join, remember it can also be called a left join. You don't need the word outer there. I just prefer to put it there. As personal preference, you don't need to do it. If we think back to the Venn diagram, the difference between the inner join and the left outer join. With the left outer join, we want all the results from our left table, in this case customers, and then we're going to be joining that to orders. So we want to return all of our customers and orders that match those customers. Let's run these two queries together and we should see a different result set. As we can see, the first query where we're using an inner join has returned 6 results. The second query where we're using a left outer join has returned 8 results. And as we can see, we've got Michelle and we've got Tony down the bottom. In their orders table, ODate and OTotal is represented by null because we don't have anything to match to, so null will be returned. Now there's nothing to stop us going further, so let's copy this first query and I'll just paste it down below. So we're joining the customers to the orders. Now how about if we want to join to the order details as well? So we can join another table by writing inner join DBO order details. Now the order details doesn't have a direct relation with the customers, but the customers has a direct relation with the orders. That's a one-to-many relationship, and the orders has a direct relationship with the order details. So one order can have multiple order details, one-to-many relationship. So we're going to be joining orders to order details, and we're going to be joining that on order ID. I need to put the word on there to indicate that that is what we're going to be using. So we're going to take order ID from the orders table and we're going to join that to OD order ID in the order details table. So we take in customers, we're going to take the customers and match those to who they've got orders. We're then going to go to the orders and match that to who's got order details. So if you think in terms of a Venn diagram, we'd have our two circles overlapping, and then we put one on top that's also overlapping, and where the three intersect and the area they cover, that would be where our results are. So let's execute this query now. As we can see, we've got quite a lot of results. What I'll do to indicate that we've got the correct results here is I'll just add the OD, the order details ID, and we should see that's quite different. Yeah, so we've got 15 rows now. So we've got Michael Smith, customer ID 1, he appears 9 times. As we can see, the order date appears 3 times, but in the order details he's got 3 rows in that table. So he's got 3 rows that match back to that one order. That one order then matches back to Michael. You will come across a lot of queries where you join large volumes of tables together, maybe 10 or more. But just knowing how to join a couple of tables together and an understanding of the difference between inner join and left outer join is a great foundation. When you start looking at queries where there's 10 tables joined together, you just expand on your knowledge. So you just build on what you know, and pretty soon you'll be able to understand queries where there's 10 tables joined together, 100 tables joined together. It is really that moment when you start working with SQL and you really get to grips with how joins work and how relationships work amongst the tables, that something kind of clicks in your head and you think, that's it, I've cracked it now. You're not afraid of pages and pages of data and pages and pages of code within stored procedures or functions. As I mentioned before, there are other types of joins in SQL that are outside the scope of this lesson. There are right outer joins, which is pretty much a left outer join reversed. So your right input, you'd return everything in your right table, and then you're matching rows from the table on the left hand side. There are full outer joins where you join everything to everything, and there are cross joins as well. We're not going to pick up on those here. I'll do a separate video on those because there's a lot to cover. Now you can have scenarios like I've got in my database here, so I'm just going to open up the tables on the left hand side. So if I select all from orders, inner join, order details, and we indicate to SQL what we're going to inner join on, so the column from each table that needs to match. So we're going to say on OID equals OD OID, and if I run that query, you can see we've got 15 results here. Now let's try that with a left outer join, and let's see what happens in terms of the results. So the query is exactly the same, we've just changed the inner join to a left outer join. and we're going to use the same tables. We're going to join on the same columns. And I'll run both of these at the same time. As we can see, our first results grid, we've got 15 results here, and our second results grid, we've got 15 results there as well. Why could that be? We've done an inner join, which should return matching in both, and we've done a left outer join, which should return data from the orders table that doesn't match the order details. But in this scenario, we don't have an order details that without an order, and an order can't exist without order details. So our order details table is really just our orders table broken down. So our orders just stores the aggregated data, so like a total, an order ID, the date it was placed, and our order details breaks that down into individual books in this case. So there wouldn't be anything in the orders table that doesn't exist in the order details table. So there'd be no need for a left outer join in this case, because something would always be present in both tables to match. What I'm going to pick up on now is something that I mentioned earlier, is when you're using the on clause to join two tables together. SQL doesn't know that they've got a direct relationship. So even though the customer doesn't relate to the order details correctly, I could write a query to say select all from customers, and I could inner join that to order details, and I could say on customer ID equals order detail ID, and I could execute that query, and I've got results. As I can see, I've returned all columns, so I've got all my customer columns, and then I've got the 3 columns at the end from the order details table. Whichever table is in your from clause, and then you join, and then you join again, that's how your column results will appear. Obviously you should be specifying which column results you want to return though, rather than just writing select all columns. If you have a select all columns query and you're looking to join 10 or 20 tables together, you will soon see that query slow down because of the volume of columns that the database engine has to return to you as the user. So as we can see with these results, we've got our customers and we've got order details. They don't have a direct relationship. The customer will place an order, and then the order will have its corresponding order details. But because these numbers match, then SQL will return that data. It's always best to join on integers, on unique IDs, obviously or foreign keys. So foreign keys would be good. So in this case, joining orders, our order ID would be our primary key of the orders table, and in order details we'd have our order details order ID, which would be a foreign key to match back to our orders. But we don't have to have integers. We could join on text. Not recommended because it's very slow, and really we don't want to be doing that. It's very bad practice. Each table should have its own primary key. If it's got a relationship with another table, there should be a foreign key in that table referencing that primary key. Everywhere I've worked, the foreign keys tend to have a good inclination of their relationships. So in my database here, I have the CID in the customers table. In the orders table, I have the OCID, so I know those two correspond together. In the orders table, I have the order ID, and then in the order details, I have the order detail order ID. So it's very easy for me to look at this database and work out how joins can happen. It's really important when working with joins to understand why they work, but also equally as important is to understand why a join would fail. Remember, we need that on clause. We need to indicate to SQL what we're joining on. If I just told it to join, it would give me a syntax error. I need that on clause to indicate that. That on clause doesn't have to just be one column. I can join on multiple columns if I need to, so I could say on customer ID equals order orders customer ID, and then there might be a necessary for an and then other columns as well. Sometimes you sort of have to work with the tables, and there might be multiple columns that you need to join on depending on what sort of data that table holds. But I hope you've got a good understanding of inner joins and left outer joins. Really hope you've enjoyed the video, guys. If you have, please do give it a thumbs up. If you've got any comments, please don't hesitate to post them below. Don't forget to subscribe to the channel. I am uploading videos regularly, and if you've got any questions, I have got my own dedicated email address, and we'll be doing any videos on anything that's sent through. That is askbeardeddev@gmail.com. Thanks for watching.